Think carefully before you push the button under your choice for the correct answer. This is your 16th lesson on algebra. You've heard of the mathematical term trigonometry, and from its name, you can guess that it's related to geometry and deals with angles and triangles. A triangle, you know, is an enclosed geometric figure with 3 straight sides. It has 3 other features, too. What are they? Yes, of course. And these angles may be of several kinds, like acute angles, right angles, and obtuse angles. Which of these is an acute angle? Yes. For more review on geometry, study the MG series of programs. Do you remember which of these is a right angle? Yes. A right angle is formed by the intersection of 2 perpendicular lines, which form 4 equal angles. Mathematicians have chosen to say that a right angle contains 90 degrees, so an acute angle has less than 90 degrees, and an obtuse angle has more than 90 degrees. The 4 right angles, formed when 2 perpendicular lines cross, add up to how many degrees? Yes, you probably recall several things about triangles. The point at the angle where the lines meet is the vertex. A triangle has 3 vertexes, or vertices. The total of the angles in a triangle is 180 degrees, but in a rectangle it's 360 degrees. In a right triangle, a triangle where one of the angles is 90 degrees, the total of the other 2 angles, naturally, is 90 degrees. Can there be 2 right angles in a triangle? No, not quite. Perhaps you remember the name of the longest side, the diagonal side opposite the 90-degree angle in a right triangle. It's called the hypotenuse. What do you think the 2 sides next to the right angle are called? Yes, the legs of the right triangle. Usually we designate the sides of a right triangle with lowercase letters, corresponding with uppercase letters, indicating the angle opposite that side. This means that if capital A and capital B are the 2 acute angles of a right triangle, small a and b are the 2 legs, or shorter sides, and then capital C would be the right angle. What would lowercase c designate? Right. If you have studied program MG7 recently, you recall the Pythagorean theorem, which states that the length of the hypotenuse is the square root of a squared plus b squared. Another way is to say that the square of the hypotenuse equals the sum of the squares of the legs. For the purpose of many statements and examples in trigonometry, we'll consider a standard right triangle with angles at A, B, and C. The right side is vertical and the base is horizontal, so C is a right angle. What do we know about angle A? Right. If we draw another vertical line, say D to E, we'd make another included triangle. We know from MA10 that there is a proportion or equality of ratios between the ratio of the line length AC divided by AB and the ratio AE over AD. This proportion always occurs in similar triangles. What are the triangles that have the same angle A and each have a 90-degree angle? Of course, this constant ratio of the base, or leg adjacent to angle A, divided by the hypotenuse, is called the cosine of the angle. Sometimes the word cosine is abbreviated as COS in lowercase. How would you describe the cosine of angle A? Yes, another trigonometric ratio is the sine, which is the ratio of the length of the leg in the reference triangle opposite to the reference angle A, to the length of the hypotenuse. Notice that this word sine is spelled differently from the ordinary word sine. Sometimes it is abbreviated SIN, but there's nothing sinful about it. It's just a ratio. Which of these is the ratio of the opposite leg over the hypotenuse? A third important ratio is the tangent. This is the ratio of the length of the leg opposite the angle referred to, divided by the leg adjacent to the angle. Which of these ratios is a tangent? Now we have the 3 important ratios which are the heart of trigonometry: sine, cosine, and tangent. There are three more ratios which are just the inverse or reciprocal of these ratios. They are called, respectively, secant, cosecant, and cotangent, but we won't try to memorize them. You should memorize sine, cosine, and tangent, however, so we'll take 30 seconds to drill. Sine, cosine, and tangent are functions of a selected angle. They may be considered for our drill as sides of a standard reference triangle with the selected angle at the left on the base and the right angle at the right. Which of these is the ratio of the opposite side over the hypotenuse? Yes. Which is the opposite leg divided by the adjacent leg? Right. Which is the opposite side over the hypotenuse? Which is the adjacent side over the hypotenuse? Correct. What ratio of side lengths is the tangent of an angle? Yes. Now what is a cosine? Yes. And what ratio of side lengths is the sine of an angle? Right. You could repeat this sequence a few times if you need to practice some more. We've been looking at an angle which increases counterclockwise from the horizontal to the right. On this protractor, you will notice the outside scale increasing in this way. The inside scale, however, starts on the left and increases clockwise. The angle and the ratios remain the same in either direction. To measure an angle, place the angle's vertex at the protractor's center mark, one leg along the lower edge, and read the angle mark where the other leg crosses the scale. Here's part of a table of trigonometric values. Notice that when the angle is 0, the length of the opposite side is 0, and the two ratios, sine and tangent, which use the opposite side in the numerator, will of course become 0. Also, when the angle is 0, the adjacent side, which is the numerator for the cosine, will be the same length as the hypotenuse. So the cosine value is 1. What is the value of the sine of 30 degrees? Yes, the sine of a 30-degree angle is 1/2, as you can see in this table. When you study trigonometry at length, it will help to memorize several ratio values, including 0, 30, 45, 60, and 90 degrees. The sine goes from 0 to 1/2 to 0.7071 to 0.8660 to 1 for these 5 values. It is interesting to note that the values for the sine of 45 degrees and 60 degrees, 0.7071 and 0.8660 respectively, are the square roots of 1/2 and 3/4. This is the result of the relationship noted in the Pythagorean theorem. What does it say about sides A, B, and C? There are a large number of uses for these trigonometric functions or ratios. Many physical relationships can be surveyed or measured indirectly by using them. In recording horizontal angles for surveys and the like, it is often standard to measure clockwise from north or other reference direction. In measuring vertical angles, the horizontal at that point on the earth is usually used. Vertical angles are often expressed as the angle of elevation. You could sight along a protractor, or use a transit or a sextant to measure the angle from the horizontal to the sun or a star, or the top of a building or pole. If you were on an elevated spot and depressed your sighting instrument below the horizontal to measure something below your level, what kind of angle do you suppose we would call it? In MA10, we solved some problems by using the length of shadows to determine the height of buildings by setting up similar triangles. We measured the shadow length of some vertical object whose height we knew to get a ratio at the time of vertical height to horizontal shadow length. If you measured the elevation angle, what function of it would involve these two legs of your triangle? Right. At a given time, the sun might be 45 degrees from the horizontal, or at an elevation angle of 45 degrees. This would give you a shadow the same length as the height of the object. What is the tangent of 45 degrees? Right. But on a cloudy day, or if you couldn't wait until the shadow reached some handy ratio of a reference height, you might use a protractor or transit to measure the elevation angle, then multiply the measured horizontal distance to the object by the tangent of the angle to get its height. The tangent of 13 degrees is 0.225. What is the height of a building which is 1,000 feet away when observed to have an elevation angle of 13 degrees? Yes, and if you know the building was 225 feet high, you could find the point 1,000 feet away by moving out until the elevation angle is 13 degrees. Remember that the span between your thumb and middle finger held at arm's length in front of you is 14 or 15 degrees with a tangent of about 0.250 or 1/4. If you walked up the mall toward the U.S. Capitol until the distance between the Washington Monument base door and the top window, about 500 feet high, fills your span, how far away would you be? Right. This 4-to-1 tangent ratio can be quite useful. Another handy tangent ratio is based on the width of your thumb, which held in front of you is about 2 degrees wide, or covers a height or width about 1/30th of the distance to an object. If you approached a city and noticed that your thumb width just covered the height of a 25-story building, which was about 250 feet high, how far would you be from it? Yes. Sometimes you may know or need to find a diagonal distance which would make up the hypotenuse of a right triangle. In this case, which ratio would you use? Right. If you were driving across western Kansas on Interstate 70 and noted that the interstate was heading 30 degrees north of west, how far west, then how far north again would you have to travel to visit Oakley if the bypass rejoined the interstate 5 miles further ahead? Yes. If there is a crane with a boom 50 feet long and a line extended 40 feet down, what ratio would you first think about to solve some problem using this information? Yes. The sine, of course, is the ratio of the opposite side length to the hypotenuse of a right triangle. Sometimes, of course, you don't have a right triangle, but have to create one. This is easy when you have a symmetrical figure such as an isosceles triangle. The base of this A-frame cabin is easily measured. It is 20 feet wide, and the roof side slopes 60 degrees from the floor. How long are the rafters? Yes. You mentally dropped a vertical line from the roof ridge, which formed 2 right angles with base legs 10 feet long. The cosine of 60 degrees is 1/2. Divide the base 10 feet by the cosine, and you get 20 feet for the hypotenuse. You may have guessed whether to divide or multiply by the cosine value, but if you used the step-by-step procedure of algebra and set up equalities, specified your unknown, solved for it, and evaluated it, you would logically find the right answer. What do you think mathematics, and especially algebra, is all about? Yes, but it's not always easy to learn without some confusion. If you repeat these programs several times, you may learn and remember much more from them. Good studying.